Assalamu alaikum. I am Tanveer Fatma. In this topic, student will be able to explain chemical reaction, differentiate between reversible and irreversible reaction, describe chemical equilibrium and dynamic equilibrium. Chemical reaction. Chemical reaction, a process in which one or more substances, the reactants, are converted to one or more different substances, the product. There is a chemical reaction in which carbon and oxygen react together and form carbon dioxide. Carbon and oxygen are the reactants. Carbon dioxide is the product, and this arrow indicates the direction of the reaction. Chemical reactions are of two types. Number one is irreversible chemical reaction and number two is reversible chemical reaction. Irreversible chemical reaction. The reaction in which all the reactants completely reacts and form product. Like carbon react with oxygen and form carbon dioxide. In this reaction, carbon and oxygen completely react and form product. This type of reaction is called complete reaction. Reversible chemical reaction. The reaction in which reacts react together and form product, and at the same time product reacts together and form reactant is called reversible reaction. This type of reaction is never go on completion and it is also called incomplete reaction. For example, sulfur dioxide react with oxygen and form sulfur trioxide. In this reaction is a reversible reaction, and this double arrow indicate that this reaction is reversible reaction. In this reaction, sulfur dioxide react with oxygen and form sulfur trioxide, and at the same time sulfur trioxide decomposes and form oxygen and sulfur dioxide. In the above reaction or in this reaction, sulfur dioxide react with oxygen, sulfur trioxide is formed. This double arrow indicate the direction of the reaction, and this reaction is reversible reaction. In this above reaction, forward reaction is sulfur dioxide react with oxygen and form the product sulfur trioxide. Look at here, sulfur dioxide and oxygen is the reactant and it form the sulfur trioxide, which is the product. And reverse reaction, in the reverse reaction sulfur trioxide decomposes into oxygen and sulfur dioxide. Look at here, sulfur trioxide is the product, it decomposes into the sulfur dioxide and oxygen. Other example of reversible reactions are sulfur dioxide react with oxygen in the presence of catalyst vanadium pentoxide. And what is catalyst? The catalyst is the substance which increases the rate of reaction but do not play any role in the reaction, and the temperature and pressure for this reaction is 450 degrees centigrade and 200 atm and form sulfur trioxide, which is in the gaseous form. Another example is nitrogen react with hydrogen in the presence of iron and form ammonia. Nitrogen react with oxygen and form nitrogen dioxide in the presence of electric spark. These all reactions are reversible reaction. Look at here, the arrow shows that this reaction is reversible reaction. Macroscopic characteristic of forward and reverse reaction. For forward reaction, it is a reaction in which reactant react to form product. Number 2, it take place from left to right. Number 3, at initial stage the rate of forward reaction is very fast and then gradually slow down. Reverse reaction, it is a reaction in which product react to produce reactant. It takes place from right to left. In the beginning, the rate of reverse reaction is negligible and then speeds up gradually. Chemical equilibrium and dynamic equilibrium. Consider the reaction. Sulfur dioxide react with oxygen and form sulfur trioxide. This reaction is reversible reaction. This double arrow indicate the reaction is reversible reaction, and it means it is incomplete reaction. In this reaction, forward reaction is sulfur dioxide react with oxygen and form sulfur trioxide, and the reverse reaction in which sulfur trioxide decomposes and forms sulfur dioxide and oxygen. Forward reaction, sulfur dioxide react and form sulfur trioxide. When forward reaction take place, initially sulfur trioxide is not formed, so the rate of reverse reaction is 0. And the rate of forward reaction is high. Why? Because of the high concentration of the reactant. As the reaction proceeds, reactant react together and form product. Therefore, the concentration of the reactant decreases and rate of forward reaction also decreases. Rate of reverse reaction has begun. Therefore, the rate of reverse reaction also speeds up. Sulfur trioxide decomposes into the sulfur dioxide and oxygen, and reaction speeds up. And the time comes when the rate of forward reaction is equal to the rate of reverse reaction. When rate of forward reaction is equal to the rate of reverse reaction, this is called equilibrium state. This is the concentration and time graph in which time is plotted at x-axis and concentration is plotted at y-axis. Look at this graph. You notice that the concentration of sulfur dioxide and oxygen initially is high, and these two things are the reactant. And the concentration of sulfur trioxide is very low, and sulfur trioxide is the product. With the passage of time, the concentration of the reactant sulfur dioxide and oxygen decreases, and the concentration of sulfur trioxide, which is product, increases. And the time reaches when the rate of forward reaction and reverse reaction becomes equal, and this state is called equilibrium state. Chemical equilibrium, a state of chemical reaction in which forward and reverse reaction take place at the same rate, is called chemical equilibrium. Dynamic equilibrium. Chemical equilibrium is a dynamic equilibrium. This is because reactions do not stop when they come to equilibrium state. The individual molecule keep on reacting, but there is no change in the actual amount of reactants and products. Dear student, this is a self-assessment exercise 9.1. Write both forward and reverse reaction and describe the macroscopic characteristic of the following equations, and you should solve this exercise.